Okay, do example number 2 here. Now this time we want to center this thing at x or at c equals 1. So we need a power series that has this form. We want something that looks like this, a sub n, and we need x minus 1 to the n. Okay, in general, this is what it would look like. And our problem is to figure out what a sub n is. So we'll take this geometric series approach again. Down here, I need to rewrite this. And one way to do it is to immediately come in here and say, okay, instead of x, I need an x minus 1. Okay, now I can't just change it like that, because what I've really done is I've subtracted another 5 from this denominator, so make sure you add it back in. Okay, now let's see what we have here. Sorry, I didn't add 5, I added a 1 here. I'm sorry about that. Here, let's do this. I subtracted, I added a 1, so I'm going to minus a 1 like that. Okay, so if I undo this, I'll just have a 1 minus a 1, which disappears. Okay, so that's good. But now that makes this 4, like so. That's a 4. All right, so we're almost there, except remember I need this form over here. We got to keep this in mind. This is what we're trying to form. And okay, so right now then I'm going to divide by 4, so I'll have this, divide everything by 4. So I'm showing you lots of detail here. Like that, and that's the same thing as 1 over 1 minus x minus 1 over 4, like that. But now we can see clearly what the r is, and the a is a 1, and the r is a 1. So now from this I can say, well, that is the sum of this geometric series. I have x minus 1 over 4 to the nth power. Okay, because that's my r in this case. Remember, where this comes from is because this thing is the same as this. Get that. So I just substitute my r, and also here I can see that this would have to be true. Otherwise, it would not be a convergent geometric series. So, and this implies this. You can see the radius is 4 now, and you can get the interval just by opening this up. Now let's see. Let me just show you that detail. So you have this, which means x less than 5 and greater than negative 3, like so. And that's our interval of convergence for this one. So here's the series, power series for this function. Okay, power series representation for that function in this interval, and it will converge for any value of x within this interval. Okay, well, what will it converge to? Well, it will converge to, for example, if I put in an f of 1 in here, well, I can use 1. And that would be a 0, right? If I put a 1 in here, it would be 0. If I put a 2 in, well, f of 2 is 4 over 5 minus 2, so 4/3. So it should converge to 4/3. So in other words, if I computed, if I put a 2 in there, f of 2 would be this. I have a 2 minus 1 over 4 like that, which is really the same as this. 1 over 4 to the n, or we'll just write it like this. And then we can see that that is a geometric series. And it would be, using our knowledge, we'd have a 1 over 1 minus 1/4, like that, which is 1 over 3/4, which is 4/3. And if you look at the original series in here, or the original function, we see that f of 2 would be 4 over 3. And that's what we got. Okay? So, and of course, naturally, this is a way that the exercise here is using the geometric series, the sum of the geometric series, to write a power series for a function that, in this case, power series about c equals 1. So we were able to get that. We can use this now in this interval to approximate this function, f of x. We can use this series to do that. But the gist of this problem is this process of utilizing this form in here to get an expansion of a power series for a given function. I should add here that we have another way to do this, and that would be to find the Maclaurin series. We could find an expansion. Well, not a Maclaurin series, since it's at 1, we'd have to go with the Taylor polynomial and see how far that would get us, see if it would get us the same series. And it would, but it would be a lot, probably not that much more work, but it would be more work, because we have to get all those coefficients and so forth. We did that, we'd end up with the same series.